Okay, ladies and gentlemen, we are working on dma060 section 8. Section 8 is where we start factoring. Factoring is a process that undoes multiplying. So let's take note of that. Factoring undoes multiplying. So if, for example, we have 4 times 5x plus 3. What we have previously learned was how to distribute. When we distribute, 4 times 5x is 20x, and 4 times 3 gives us 12. What we're going to do now is we are going to be given the 20x plus 12, and we're going to be asked to factor it. So we're going to look at the two whole numbers and see if they have anything in common. Their greatest common factor is the number 4. When I factor 4 out of 20x, I'm left with a 5 and an x. And when I factor 4 out of the 12, I'm left with a positive 3. So if you see, a moment ago, we distributed to get this, and then I took that answer and I undid it by factoring out the GCF first. Once I factored out the GCF, I then wrote what I had left. So to begin with, how we're going to start is that we are going to have some sample problems that we're going to do where we are going to find the greatest common factor. So we're going to take the numbers 14, 24, and 60, and we're going to find the GCF. We're going to do this using calculator steps. So what I'm going to do is go to my calculator and press the button Math. I'm going to arrow to the right, and then if you notice, I'm going to choose number 9. So we pressed the Math button, we arrowed right to NUM, and we chose number 9 where it had G, C, D. Notice we're only going to be able to type in 2 numbers at a time. Our first 2 numbers are 14 and 24. So I'm going to type in my 14, the comma, and a 24. If I tried to type a third number, I would get an error. I press enter. Their greatest common factor is a 2. Math, arrow right, choose number 9. Now I'm going to take the answer I just got, and then my last number was 60. So my greatest common factor of these numbers is a 2. I did that with the first number, the second number, so we had the 14, the 24. I did the same steps again. I used the answer for those, which was the 2, and then the 60, and they gave me as my final solution a 2. So anytime you have whole numbers, you may use this process to get your greatest common factor. Not every time will you be given numbers. You will oftentimes be given variables. So let's say we have x cubed y. Let's say we have x squared y squared, and we have x to the 4th, y to the 5th. If I want to find my greatest common factor for these, I'm going to show it to you first visually. The first one has 3 x's and a single y. The second one has 2 x's and 2 y's. And the last one has 4 x's and 5 y's. So my greatest common factors are going to be, when I do the GCF, greatest common factor, we know there's going to be an x, we know there's going to be a y, but how many of each? So All of them have one x. All of them have two x's. They don't all have 3 or 4. So the most x's that they both have is 2. So we're going to use x squared. For the y's, they all have one y, but they all don't have more. So in this case, there's only the one y, and we don't write the understood one in our answer, so x squared y. So what this is leading us up to is that we're going to be given a polynomial, and as we move into our next sections, 9, 10, 11, 12, 13, 14, as we are factoring, our first rule of thumb is we're going to be sure that what we have is in the correct order. And if our polynomial is in descending order, the first thing we're going to look for is always going to be the GCF. So that's what we're going to do here is we're going to start with the GCF. So let's do a couple of examples. Here we have 5m cubed minus 15m squared. So what I'm going to do is look at these two. I have a 5 and a 15. The greatest common factor of both of those is going to be the value 5. Both of them have an m. What's the most m's they both have? This one has 3, this one has 2, so they both have at least 2 m's. So I put my GCF first. If I factored 5 from 5, it's 1. And if I take 2 m's away from 3, I'm left with a single m. Then I have my minus sign. 5 goes into 15 3 times. M squared goes into m squared. It cancels out. So my answer is going to be 5m squared, parenthesis, m minus 3, close your parenthesis. Okay, let's do another, and let's do one that has multiple variables. So here I'm going to have 4x squared y cubed minus 6x squared y plus 8xy. So I'm going to look at my whole numbers 4, 6, and 8. They're all even, and the biggest number that goes into all of them is going to be a 2. They all have, the most x's that they all have in common is 1x, and I have y's. The most y's they all have in common is 1y. So from this first term, 2 goes into 4 twice. When I take 1x away from 2, I'm left with 1. 1y from 3 leaves me with a y squared. Then I have my minus. 2 goes into 6 3 times. The x from 2 leaves me with 1, and the single y cancels out. The 2 goes into the 8, positive 4. My single x's cancel, my single y's cancel out. And that would be my final solution. Another scenario that we will work with is that we will be not dividing, but we will be factoring 4 terms. So let me make a note up here. To factor 4 terms, we're going to use a special method. The special method we're going to use is the grouping method, which is really what we were just doing, factoring a single term out. So let me start with this example, 5m plus mn plus 20 plus 4n. The way I like to look at this is I'm going to factor the first 2, the last 2, and I'm going to use the sign that we have in the middle. My first 2 have a common factor of just the letter m. M from this leaves me with 5. M from here leaves me with plus n. I use the sign given. These 2 numbers, 20 and 4, have in common the number 4. 4 goes into 20 5 times. 4 goes into 4 once. I'm left with just an n. So when I write my final answer, it's going to be 2 parentheses. And if you will notice, both parentheses have a 5 plus n. That is their greatest common factor. I'm going to take the values that I factored out that are in the front, and they're going to make up my second parenthesis. Now I have completely factored that polynomial. Now let's do a polynomial that's going to give us several things to consider. Here we have 12x squared y minus 42x squared minus 4y plus 14. Okay. Now the first thing we want to know, is there a GCF? And we have a 12, a 42, a 4, and a 14. They are all even numbers, so I know 2 is going to go into all the numbers. 4 will go into 12, but it's not going to go into 14 because that only has a 2 times 7. So our GCF is going to be the even number 2. That's going to leave us with 6x squared y. Half of 42 is 21, x squared. Half of 4 is 2, and then half of 14 is 7. So this 2 is still going to get brought down when we finally do our final solution, and we have our 2 sets of parentheses. However, in between, let's do our factoring. First 2, the last 2, and use the sign in the middle. These 2 both have in common a 3 and an x to the second power. 3 from 6 is 2. The x squared cancels. I'm left with a y. 3 goes into negative 21 minus 7. The x squared here and here both cancel. Always use the sign given. These 2 have nothing in common, so if there's nothing, we're going to write the understood 1. Now, notice I'm going to put the 2y and the 7, but let's check on this sign. We didn't have a minus here before, we had a plus. A negative and a positive is a negative. A negative times what gives me a positive? A negative. So what was in common is the 2y minus 7. And what I'm going to now have to do is take what we had factored out in the front, the 3x squared minus 1. That is what is going to give us our second factor. And there we are. We're done.